An introduction for pi donor, sigma donor, and pi acceptor. Sigma donor has only one electron pair at donating atom. For sigma and pi donor has more than one electron pair at coordinating atom. Sigma donor and pi acceptor has double or triple bond. Sigma donor and D acceptor, ligand is coordinating by phosphorus sigma donor and D acceptor. As we can see, this sigma pi donors and acceptor involved with orbital overlapping. For sigma donor, the sp3 orbitals overlap with the D, which is dz2 and dx2y2. For pi donor, the d orbitals are dxy, dxz, and dyz. For pi acceptor, the d orbitals are dxy, dxz, and dyz. These are the spectrochemical series. As we can see, the pi donor range from the iron to the O2, while sigma donor is OH2 and NCS. For pi acceptor, these are the ligands. We know that metals has 5 available d orbitals. 2 quadratic orbitals are e.g. dz2 dx2 minus y2. For 3 orbitals is t2g, dzx, dyz, and dxy. T2g orbitals, all x's never go through an area of electron density. Areas of electron density are lobes of d orbitals. For Eg orbitals, which is dz2 dx2 minus y2, go through all 4 lobes. For pi donor, the p orbitals are attached to the lobes. It is because there are side-to-side overlapping between the lobes and the orbital. The lobes are not on the axis. Then the ligand can approach along the x-axis and overlaps the two lobes side to side. For sigma donor, lobes are on axis. It is because it is head-to-head overlapping, making it sigma donor. It usually involved in Eg orbitals dz2, dx2, and y2. For pi acceptor, it is the metal that is donating the electron density to the pi orbital with pi electrons. This is what we call as pi acceptor. It experiences a pi back bonding. The pi acceptor deals with T2g orbitals. Ligands orbitals approach the d orbitals, the electron sharing from pi electrons of ligand to the d orbital. For nitrile, C-N is pi acceptor. This is because the ligand orbitals approach the d orbital. The metal donates electron density to the pi orbital with pi electrons. It experiences a pi back bonding.
Alright, let's look at this example. We have PF3, which is phosphorus trifluoride, and also we have PME3, which is trimethylphosphine. So as we look at this structure, this both structure has the trigonal pyramidal structure, and the differences is in between the fluorine and methyl. So let's look at this phosphorus trifluoride. Phosphorus trifluoride, we have 3 fluorine atoms which attach to the phosphorus, and this phosphorus atom has 1 lone pair electron that can be donated or attached to the metal center, and also they have a single bond for each attachment from the phosphorus to the fluorine. So therefore it is known as the sigma donor electron, sigma donor structure. And therefore, when we go to the trimethylphosphine, we have 3 methyl atoms, 3 methyl molecule which attach to the phosphorus, and this phosphorus has one lone pair electron which can be donated to the metal center. Therefore, it is known as the sigma donor ligand. So as we can see here, the differences is in between fluorine and methyl molecule. Therefore, fluorine has the most electronegativity. Therefore, the most significant ligand for this, the most significant interaction for this ligand is Pi Acceptor ligand. While for PME3, which is trimethylphosphine, the most significant ligand for this is sigma donor, because it is less electronegativity of methyl molecule.
For the next question is third pyridine. This is the structure of the third pyridine, and it is C15, H11, and 3. It acts as a Pi acceptor. It has pi back bonding, or called pi back donation. It has double bond at coordinating atom, and this one is acetyl acetone, or also known as ACAC. This is the structure. It has more than one electron pair at coordinating atom, and the CO has only one electron pair.